Welcome to the Explainer. Today, we're jumping right into the physics behind a pretty incredible piece of technology, the ballistic missile. We're going to figure out what that word ballistic actually means.
So let's start with a question that really just sounds like science fiction, right? How can anything cross an entire continent in less time than it takes to order a pizza? Well, the answer isn't some futuristic tech. It's all about pure fundamental physics.
And the whole secret is hiding in that one word, ballistic. You see, that word describes a very specific kind of journey. It's not about having an engine running the whole time. It's about one single, incredibly powerful action right at the beginning.
So what is a ballistic trajectory? Honestly, it's pretty simple. Just think about throwing a rock as hard and as far as you can. You give it one huge push, and then that's it. It's on its own. It just coasts, following this perfect, predictable arc that's shaped by gravity and the momentum you gave it. That right there, that's a ballistic path. And this is where it gets really clear. A ballistic missile is like that throw. One enormous push, and then it just coasts. A cruise missile, totally different. It's basically a small, unmanned airplane. Its engine is on the entire flight. It stays low, and it can steer itself. We're talking about two completely different ways to fly.
So this whole journey, this giant throw, can really be broken down into three main parts. And we're going to follow the missile through every single one, from the ground, way up into space, and all the way back down.
All right, let's kick things off with phase one. This is the most violent part of the whole trip, the boost. It's all about raw power and incredible speed, and you know what? It's over in just a few minutes. Now, during the boost phase, these massive rocket engines do all the work. And this is key. It is the only time the missile is actually under its own power. It's like a pitcher winding up and releasing the ball. This short, super intense push gets it going over 15,000 miles per hour and sets the angle, the speed, everything for the rest of the flight. So after all that noise and fury, what's next? Well, it's actually the longest and quietest part of the trip. The engine's cut out, and for the next 20 minutes or so, the missile is just coasting. It's completely committed to the path it's on. And for all that time, it's nothing more than an object sailing through the vacuum of space. It's traveling thousands of miles an hour with absolutely zero power. No engines, no steering. It's just silently following that arc it was given right at the very beginning. And this brings us right back to that stone we talked about. All the incredible, complex rocketry, that's already done. From this point on, it's just physics 101. The object is basically falling, but it has so much sideways speed that its fall creates this huge, graceful arc over the curve of the planet. But you know, what goes up must come down, right? After coasting for thousands of miles through space, gravity finally starts to win the tug of war. And this begins the final and incredibly fast part of the journey. We call this the terminal phase. The payload, or what's called the re-entry vehicle, just plummets back into the atmosphere. And we're talking hypersonic speeds here, many, many times faster than the speed of sound. It's this fiery plunge that ends that long, silent arc that started just a few minutes ago. Okay, so let's put it all together now. When you look at the whole picture, you really start to get why this unpowered arc is the one thing that truly defines this technology. It all starts with that one short, unbelievably powerful push, just enough to get out of the atmosphere and set a course. Which leads to a long, totally unpowered coast through space, where it's just an object following the basic laws of physics, and that whole thing ends in a final and totally predictable fall back to Earth as gravity pulls it down. Push, coast, fall. That's it. That's the entire journey. So when you get right down to it, this is what you absolutely have to remember. The word ballistic isn't even really about the missile itself. It's about the path. It describes any object that gets thrown and is then just left to follow a predictable, unpowered arc governed by gravity. And that predictability, well, that's both its greatest strength and its greatest weakness. Which leaves us with a final question to think about. In a world full of smart technology, of things that can change course mid-flight, what's the role for something whose most important feature is that once you launch it, its path is literally set in stone?